My name is Elliot Battles, and this is my solution for Task 2 for the Coursera Capstone for the Cloud Computing Specialization. I'm going to walk through my Spark streaming solution, and I'm not going to walk through everything I did, but I wanted to highlight a few things so I could kind of just show that this is a working app. And so, in order to implement this, I wrote a Spark streaming program, and I'm going to show you how I answered question 2.3. I wrote this in PySpark, so you can see the code here. I set up a streaming context to basically look at I streamed it from HDFS. Just instead of setting up like Kafka or something like that, I thought this would be the easiest to kind of get it going. And so essentially what I have going is I'm looking at this folder in HDFS, and then every 3 minutes it's looking for files, and then it is splitting the data. I've got some helper functions here to help me return the top 10, and then also to just convert things to strings. So when I store it into DynamoDB, I can store it as a string array. And so I'm calculating out I'm setting up a key value pair here to do the origin, the destination, the carrier, and then the arrival delay, and then combining that to basically give me a sum and count, which I can then use to calculate the average arrival delay by carrier for each source to destination. And then I'm grouping those together, and then finally pulling out the top 10, leveraging my helper functions, and then just converting it to a string. And then finally I'm just saving the output to S3 so that I could then load it up into DynamoDB. And so this is my streaming program, and I just have it terminating after about 20 minutes. So I'm going to execute it here. I'm running EMR, and so I'm going to execute the streaming, and then I'm going to, because PySpark is looking for new files, I'm going to I had previously, in the first task, I had all my data in about 29 different files, so about 9.8 gigs split over these 29 files, about 300 megs each. I'm going to copy that into EMR so that the streaming program will recognize the new files, and then pick them up and start executing the PySpark streaming program. So I'm going to demonstrate that now. So, and I'll make some cuts to this video so you're not watching just the code run, but you can see here it's starting to execute. And then I'm going to go over here to the EMR instance, and I'm copying over using S3 distributed copy. I'm copying over from my 29 files I showed you earlier in S3 into the Hadoop folder that the streaming application is looking for. So I'm going to go ahead and execute that step. So that's running, and you can see here the streaming context is started, so now it's just waiting for a file. And so once this runs in, it'll start executing my code. So you can see here now it has picked up the new files that have moved into HDFS and has started to execute against them. So I've streamed in the files into HDFS, and now the streaming application has picked them up and is starting to execute the code I've written. So my Spark application is finished running, so it takes about 12 minutes roughly to run this, and so now it should be saved as a text file in my S3 instance. So you can see here the different folders it was creating on the different intervals, and here are the text files for the output. And so what I had previously done is I'd taken these text files, and I've already done this, but I used Spark SQL to save that into a Hive table, and then ultimately used Hive to upload the final output into my DynamoDB instance that I could then query against. So here's my DynamoDB with the output of my streaming application, and so I can look up LGA to Boston, and they're not ordered, but I ordered them in the solution. Here are the top 10 from a minimum arrival delay for from LGA to Boston. Uh, OKC, Oklahoma City to Dallas Fort Worth was another one. So again, I have that for the solution set, so you can see all the different carriers and the minimum delay for that question. And so basically the process I followed for all of them. I just obviously changed the code to reflect whatever the question was, and I saved them all here in DynamoDB. So DynamoDB, and that's essentially how I accomplished task 2. So thank you for your consideration. I look forward to seeing other solutions to this problem that my classmates have worked up. So thank you very much.